There's a missing part to all of these, okay? So what you're gonna do is you're sort of gonna say like this: yellow, 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 and then what you just put on the back here is you can write this down if you want. Differentiate diffo yellow parts or whatever color you're using. Okay. Now let me explain what that means. In the case of sine inverse 6x, okay. Oh, and there's also that other thing. A is always 1. If you set A always equal to 1, then this will work every time. Okay? Just always set A equal to 1. And then you'll see everything else just works perfect. Okay? Now, here's what you're gonna do. You're gonna write down this 1 over square root of A squared minus blank squared, and then differentiate the blank part. Now, the blank part is the yellow part. Okay? So, is everybody happy enough that A is always 1? First thing. See the way instead of A squared I'm now going to have? I'll have 1 squared instead. So I'm going to have 1 over the square root of 1 squared. Okay? Now, instead of x, what am I going to have instead? 6x. And what's 6x squared? What's 6x squared, lads? 36x squared, right? What's the last part say? Differentiate the 6x. What happens when you differentiate the 6x? What happens when you differentiate it? You get 6. So what's your answer? 6 over the square root of 1 minus 36x squared. That's your answer. Done. Nothing you can do. Okay, you try part 2 on your own when you're ready. Tan inverse 3x. Okay, you're now doing tan inverse 3x. You choose the tan formula and you put a equals to 1. Instead of using x, you're now going to have 3x. Differentiate the 3x over here. What happens when you differentiate the 3x? Did anybody get 3 over 1 plus 9x squared? You got that? Yeah? All good? Awesome. All right. Let's try question 3. Off you go. Okay. You've selected that sign. You replace the a with 1. You replace with what used to be the x is now 2x plus 1. Now you're going to have to differentiate 2x plus 1 on the top. Differentiate 2x plus 1, you get 2. And on the bottom, you're going to get the square root of 1 minus 4x squared plus 4x plus 1. The 1's cancel. And I'm going to be left with interesting function that. Who got that? Alright, we're good. Alright, let's move on the show. So here's what we're going to do. Okay, in this case, I would say a equals 1. But instead of x, what do I have instead of x? I have 3 over x instead. Okay, so if I do this rule, it's 1 over a squared, which is 1 squared. Then it's minus 3 over x to be squared. And then I differentiate the 3 over x. Is that okay? As long as I differentiate the 3 over x, what's my answer? It's technically 3x minus 1, isn't it? Well, obviously you differentiate 3x minus 1. Minus 3x to the minus 2. Minus 3x to the minus 2 on top. And on the bottom, what I'm going to get here is I'm going to get a 1. Good. I'm going to get 1 minus 9 over squared, right? Now there is a trick here. I'm going to show you the trick. Over here, imagine I gave them a common denominator, as in it's x squared over x squared minus 9 over x squared. Why are you talking about this part here? Okay. What's my next step? X squared minus 9 on the top, and yeah, but it's no point. Doesn't do anything. Okay. The rule I always remind you guys of is what's root 16 over 25? 4 over 5. Technically, you treated it like this. Okay? So why did I show you this? What are you expecting me to do here next? Oh, okay, be careful with that, Charlie, now, alright? You're right about the bottom part. It's root x squared, okay? But please remember, x squared minus 9 can't be square rooted because it's not x minus 3 by x minus 3. It's actually x plus 3 by x minus 3. It's not the same bracket twice, so it can't be square rooted. Okay, so you can't square root the x squared minus 9. But you can square root the x squared, can't you? And what happens when you root the x squared? What you get? Just what? Just x, isn't it? Now we can go back up here, and what we get is minus 3 over x squared. I'm going to take that up and turn it upside down, haven't I? For those of you that aren't certain, this yellow part here, including the square root, is exactly the same as this yellow part here. One of them is being divided by the other one. That means I get the denominator, bring it up, and turn it upside down. And what I should get is... So what's my answer now? Anybody? Yep, done. Just check the back of the book for that, just in case. But I'm pretty certain. Okay. Golden rule, a equals 1. You get 1 over 1 squared. Instead of x, you have x over 4, don't you? So you put x over 4 squared. Is that cool, you guys? Now, the next thing is differentiate the x over 4. 1 quarter. Everybody happy with 1 quarter? It was 2x, the answer would be 2. It's 1 quarter x, so the answer should be a quarter. Okay? And that brings me down to this stage where I have 1 over 1 plus x squared over 16 multiplied by a quarter. I'll probably get a common denominator on the bottom. 1 over 16 plus x squared over 16 times 4. Is everybody happy how I transitioned the two yellow bits together? They're the same thing. Does everybody know what I did? Common denominator, I've changed the 1 into 16 over 16. And then I merged the fractions together, okay? Now I've got to multiply this by 4, which means I can just simply go after the I can simply just go after the bottom there. So it's going to be 16 plus x squared all over 4. What should I do with the bottom? The yellow part, what should I do with the yellow part? Just turn upside down and I have my answer then, don't I? What's my answer? 4 over. Now, an interesting one about this is, okay, what happens if we did it the other way? What was the, it was x over 4, wasn't it? And we just said a equals 4. Would it work? I think in this case, it would. In this case, it would, alright? Now, some of you are probably saying, so what I find when I'm teaching this is some of you struggle to tell the difference between part 1 and part 2 and whether you're allowed to put a equals to 1 or should you not put a equals 1. If you do every question the same way, you won't have to think about it. You'll just do it the same way every time. Now, let's be honest. Just chucking A as 4 is a lot easier than what we did over there. It's easier and it's faster. My concern is you'll get the choice wrong. You can't do it for part 1. So what I'm saying is I have 1 minute to resolve. If you're confident you can change between both methods, be my guest. Okay? All right. All right. Let's move on. So, this one. What you reckon? Give it a go. Go on. So, my general way is A equals 1. What used to be X is now equal to cos X instead. So I'm going to go for tan. It's going to be 1 over 1 squared plus cos X 2b squared. Then we're going to differentiate the cos X. What you get when you differentiate cos X daily? Minus sine X, okay? You differentiate cos X, you get minus sine X. And on the bottom you have 1 plus cos squared X. Alright, what you need to replace X with? That's what to replace X with? Pi over 6. So minus sine pi over 6. 1 plus cos pi over 6 squared. Because my calculator is in degrees, I'm going to use sine 30 instead. And I'm hoping somebody beat me to this. Did we get minus 2 over 7? Awesome. Alright. So, I did questions 1. I just did 1, 4, and 8 to be honest. Okay. So, if I did 1, 4, and 8, you guys should do 2, 3, 5, 7, 9, and 11. Red is what I did in class, green is for homework.